here to talk about walking water. So, how can water walk? And does it have the same reaction with vinegar and soda?
How can it?
We'll be talking about that later. So, to start off this experiment, you'll need paper towels, food colouring, and water. But, considering we're using variables, you'll also need some vinegar and some soda.
Let's get started.
My hypothesis is that in A, which is the vinegar, B, which is the soda, and C, which is the water, will work and mix. I think this because the paper towels that are in between them will absorb up the mixture, and then gravity will pull it down through the paper towels and they will mix into the middle cup. But on the other hand, in D, I predict that it won't mix and it won't work because the vinegar and the soda have different densities, is what I think. And when they get into the middle cup, they will stay on their sides. What I've prepared earlier. So, in the vinegar, we have yellow and red. In the soda, we have blue and red. In the water, we have red and green. And in the vinegar and soda, we have blue and yellow. Now, to do the paper towel part, you have to fold it in half, in half again, and in half again. And you have to make a little crease in the middle. And you put it in between the colour and the non-colour. So, we'll be doing this for each type. As you can see, the mixture has already started to crawl up the paper towels. Now, all we have to do now is leave it for 2 hours and it'll work itself out.
2 hours later.
Now, as you can see in the vinegar, the food colouring hasn't completely entered the middle cup, but there's this weird sort of purple liquid in there. Now, this might be the main ingredient from the vinegar, which is acid, and acid might not absorb food colouring. So the food colouring hasn't still yet entered. As in the soda water, it has fully absorbed the food colouring. So it has been drawn into the middle cup and made a dark coloured purple. Now, the thing is, some people think that the carbon dioxide bubbles might affect the way it has been drawn into the middle cup, but it doesn't, because food colouring doesn't have anything to do with the gas in the bubbles. So it has normally entered the middle cup. And the same as with the water, it has fully absorbed the food colouring and drawn it into the middle cup. In D, which is the vinegar and the soda, the vinegar has done the same as with A, and the soda has fully absorbed it like it should have, the same as B. My hypothesis is correct in B, C, and in the soda part of D. But it has been incorrect in A, which is the vinegar, and the vinegar part of D. You can do this experiment at home, but make sure the food colouring doesn't get in your clothes, or else Mum won't be happy. Thanks for watching!